We're delighted to have with us Manuel Lima from Google UX, joining us from New York City. Manuel is a fellow of the Royal Society of Arts, and he was nominated by Creativity magazine as one of the 50 most creative and influential minds of 2009. He's the founder of visualcomplexity.com, a design lead at Google, and a regular teacher of data visualization at Parsons School of Design. Manuel is a leading voice on information visualization and has spoken at numerous conferences, universities, and festivals around the world, including TED, Ars Electronica, and IXDA Interaction. He has also been featured in various publications and media outlets such as Wired, The New York Times, Science, Nature, Business Week, and Fast Company, to name just a few. He's the author of 3 books, Visual Complexity, The Book of Trees, and The Book of Circles. And he also has 2 kids, he told me, so I don't know how he's writing books and doing all this stuff. Well, I have 3 kids, so I don't know how I'm doing all this stuff too. So please join me in welcoming Manuel Lima to the stage, everyone.
All right. All right, perfect. Well, thank you so much for the kind introduction. That was awesome. I think it's a really appropriate theme today, creative growth, because the presentation that I'm going to give to all of you right now is really about a story about my own sort of creative growth, in a way, my own personal journey through some of the past maybe 15 years or so. This is a tale that kind of starts when I was maybe 16, and I wrote a book by Bruno Munari, the famous Italian designer Bruno Munari, called Design as Art. And that was a huge influence in my life and in my career as a designer. In this book, if you haven't read it, I highly encourage you to do so. In this book, Bruno Munari mentions that culture today is becoming a mass affair, and the artist must step down from its pedestal and be prepared to make a sign of a butcher's shop. And this utilitarian, pragmatic, and pluralistic view of design really resonated to me at the time and really stick with me for, since, until today. And then 2 years later, after reading this book, I moved to the beautiful city of Lisbon to study industrial design. This was also, of course, an important foundation in my career as a designer, an opportunity to understand engineering, materials, but also ergonomics, usability, and ultimately user experience, which is an area that I know so well and I've been involved for the past 10 years or so. After a short design internship at Convergent in Denmark, a country where designers are a bit like demigods. I don't know if you've been to Copenhagen, to Denmark, but if you are a designer, you should just go there and have that experience of being in a taxi, being in a cab, and then telling the driver that you are a designer, and they look at you as if you're like a nuclear physicist of some sort, which is a great feeling to have, really boosts your ego as a designer. And then after this short internship in Denmark, I moved to New York City to do a Master of Fine Arts at Parsons School of Design. And looking back, I think this is arguably the most important period for me in terms of experimenting with all domains of knowledge. I look back and the metaphor that comes to mind is all these multiple doors of new information, new knowledge opening in my mind all of a sudden. And I tried everything you can think of, from motion graphics to game design, physical computing, which I didn't like, by the way, interface design, information architecture, you name it. I was really wanting to try everything I could. Game design was starting to be a big thing back then. I was really fascinated by the whole concept of entertaining a user for a long period of time, right? Captivating their attention constantly. So I was reading to game design, the theory behind game design at the time. I was also becoming very interested in information design, and specifically about epidemiology, how diseases actually spread within a social context. And this was actually a group project we did that gathered my 2 sort of like passions back then, information design and epidemiology. And it was trying to compare the spread of viruses. In the left, a human virus, SARS, back then was pretty big. And on the right side, a computer virus, my doom. So to see if there was any sort of resemblance in the spread of a virus between, again, a biological virus and a computer virus. But it was really when I took a class, an information design class with an amazing teacher of mine called Christopher Curran, that he showed us this particular diagram. And since then, I became obsessed with this diagram, but also with this underlying discipline of data visualization. This is called the Understanding Spectrum by Nathan Shadroff, and it shows how data leads into information, information leads into knowledge, and knowledge ultimately leads into wisdom. And even though my background was actually in industrial design, as I just showed you, I was super enticed to be part of the spectrum, specifically building bridges between information and knowledge, right? Between this divide between producers and consumers. So immediately for my thesis project, this was like a second-year program, and by the end of the second-year program, we had to do a thesis, a final project. And I was, again, very interested in epidemiology, but also how the spread of diseases are tied with the spread of information, right? The idea of a word of mouth. So word of mouth or memetics, how memes spread in a social context, has been a huge amount of, has caused a huge amount of interest for social sciences for a long period of time. But it has always been extremely hard to understand and to map how information spreads from person A to person B and who gets contaminated in the process. But then, of course, came the internet, came the blogosphere, and it was a lot easier to understand how all this information, all these memes, these bits of information actually spread from different people within the web. So my final project was really a visualization tool to map how memes, how bits of information spread across the blog space. And this is, again, this was back in 2004, at a time where blogs were the brand new thing, right? They were meant to replace all types of newspapers and media you can think of, which of course turned out not to be the case, as many times happened. But in order to really understand how you can actually visualize the blog space or the blogosphere, I started collecting dozens and dozens and hundreds of projects visualizing all types of networks that you can think of, right? Which became visualcomplexity.com, a website that's still available for anyone who wants to browse around 1,000 projects in this domain. And the goal, again, looking back at the quote from Bruno Munari, has been to really have this pluralistic approach, right? It was really trying to leverage a critical understanding of all visualization methods across a broad array of disciplines, right? As diverse as biology, social networks, or the World Wide Web. It was really the only way we can really understand how every single human being across the world is trying to map and make sense of these really complex structures. And some people browsing the website and in different reviews have called this the ultimate map of maps, right? Which is something pretty evocative for me as well. And a few years later, my first book came out, Visual Complexity, Mapping Patterns of Information. And it really captures a lot of the knowledge and a lot of the content that you actually see on the website pertaining to visualizations of networks. I'm always obsessed, however, with the origin of things, right? So I wanted to go further back. I wanted to really understand, but networks are great in their own way, but who are actually the first human beings depicting and mapping and illustrating different types of networks? And that took me back to tree diagrams. Almost 1,000 years of attempts at understanding and depicting hierarchical structures through a tree diagram. And my first chapter on visual complexity is actually called The Tree of Life. And immediately after, well, not immediately, but maybe a few months after actually finishing the book, I was thinking, this topic is too big for one single chapter. That's why then my second book came about, which was called The Book of Trees. And this is really covering almost 1,000 years of human attempts at depicting hierarchical structures of all types that you can think of using a tree diagram. And again, the same sort of like mental exercise I went through, like, can I go even further back? Can I go to the earliest types of diagrams and illustrations created by humans? And it definitely took me way back. It took me 40,000 years ago. And it took me back to these primordial rock carvings or petroglyphs around regions of Africa, Scotland, Native America, Australia. And of course, many of these engravings, if you happen to notice, were actually circular in shape. And of course, not by accident. And these are hundreds of diagrams, charts, maps, and illustrations that end up being featured in my third and last book, called The Book of Circles, covering 1,000 years of user culture across almost every single domain of knowledge you can think of. And this is actually the front and back cover of the book, launched last year. This is the table of contents for the book, but it's also taxonomy, right? It organizes 21 visual models of circular diagrams grouped into 7 primary families. Again, through 1,000 years of evolution. And the book was, I think even in just a few weeks, it got a lot of praise, and I really appreciate that from different media types, from publications like Nature and Science, Fast Company, and many others. And if you are actually a new reader of my work, if you've never actually seen any of my books, I always encourage people to actually read them in reverse order, starting from the last one, The Book of Circles, and going all the way back into my first, Visual Complexity, exactly because of that mental exercise I explained to you, right? It's almost like starting at the very origins of the human desire to map and depict information, going forward into the most contemporary form, which is network visualization. So I just went through like a little bit, like in a few slides, kind of like my creative growth in a way, right? My sort of journey into this domain. And it all maybe sounded good, but then many of you were wondering, this is great, but how is this guy actually making any money in the end of the day? So as it turns out, when I started actually putting together Visual Complexity and archiving all these projects, I also started working as an interaction designer at RGA in New York City, which has grown substantially since then, since this was back in 2005. And believe it, those who are familiar with RGA know that now it's like this mammoth around the world. But back then, they had one single office in New York where I was working out at. And what's interesting is that looking back, I feel like this was the beginning of what you might call a split career, right? I felt like my life has been divided since then. On one side, I had a very productive UX career, working in places like Nokia, when it was still a big thing, Microsoft, Code Academy, and many others, building a variety of UX work on every platform you can imagine, from mobile, desktop, TV, campaigns, websites, software, mobile applications, you name it. I think I've been involved in every single touch point that we can have when it comes to a digital experience. But then on the other side, this other side of my life, I was, again, writing books, I was teaching, I was also speaking on many of these topics around the world, really. And it even took me to the main TED stage, which is by far one of the most nerve-wracking experiences you can think of. But recently, I discovered this sort of like citation, this like definition online of what a passion project is. And I think it describes pretty well, at least for me. And it says that a passion project is something you work on, often outside of your chosen career path, that gives you satisfaction, gives you happiness, and puts you in a state of flow. And I think that's what I enjoyed about having this like duality in my life, because in one way I had my 9-to-5 job, but I had this passion project on the side that, again, put me into that state of flow. And that was really important for me to have that in my life. And this, of course, has been a really long passion project, 14 or 15 years to be exact. So I learned a lot along the way, as you can imagine. So I definitely want to share with you a few insights that I learned over the past 15 years or so. So one of the major things that I learned during this research that led to 3 books is I learned to appreciate nature as an endless source of inspiration. This is a quote by the Roman philosopher Seneca, who says, "All art is but imitation of nature." And through my books and research, you can actually find some interesting juxtapositions like the ones that I'm showing here. On the left side, you have what looks like to be a jellyfish, but it's actually a colony of microorganisms called hydroids. And on the right side, you have a visualization of the most searched musical artists in several Italian regions from 2009 to 2014. Here you have, on the left side, of course, a detailed view of a human eye. I think anyone can sort of understand what that is immediately. But then on the right side, you have a visualization, a map of blood sugar readings and doses of insulin throughout a year of a single person. Here on the left side, you have an impressive shot of Jupiter's south pole. And then on the right side, you have, again, a visualization of 30 years of the New York Times. Each dot, little dot that you see there, represents one news article, and its color shows the year that it was published. All the articles are represented by cooler colors, while recent articles are indicated by warmer colors. Here, another interesting comparison. You have, on the left side, you have a map of the gravity of the North Polar region of the moon. And on the right side, you have a visualization of daily flights to Milan from all worldwide cities. So you see Milan right at the core of this radial chart. And then the city's distance from Milan is proportional to the number of daily connections between Milan and that city. That's why London is actually closer to Milan than any other city on the specific map, because it has a lot of daily connections. And then the size of the bubble actually indicates the overall number of the overall traffic in each city. Then these are a few. This is actually one that is featured as a page spread in my latest book, The Book of Circles. And it really shows and displays the omnipresence of the circle in nature, right? On the left side, you have these microscopic structures. These are called liposomes. They are microscopic organisms of 1/10 of a millimeter, or 0.003 inches in diameter. And then on the right side, you have supernovas. These are massive, structures in our universe, dying stars. And it really shows how, again, our ancestors were fascinated by some of these structures that they couldn't even sort of grasp and understand. Here, it's also another sort of interesting juxtaposition that really shows, again, in this case, the omnipresence of the network, not so much the circle. On the left side, you have the neural network of a mouse, which is very similar to our own at this specific scale. And then on the right side, you have a shot of the Millennium simulation. It was able to recreate the history of 20 million galaxies in 25 terabytes of output. It was one of the largest simulations ever of the growth of cosmic structures. And again, I love this sort of juxtaposition in the sense that, are we in the presence of not just a universal structure, but are we in the presence of this interesting comparison between the smallest scale of human knowledge and the largest scale of human knowledge, and how everything is kind of one in the end. So apart from this huge appreciation for nature, I also learned to appreciate history under a very different light altogether. This is actually a quote from myself, and I point this out in my second book, The Book of Trees. And I say that given the recent surge of interest in the field, it's tempting to contemplate information visualization as an entirely new discipline rising to meet the demands of the 21st century. And in many ways, this is how the field is actually normally portrayed in most books that you can buy on this topic. They basically portray this massive explosion that happened in the 21st century, and some books, not even all, but some might go as far back as the late 18th century, just for extra context and a sense of origins of where this actually came from. But that's it. They don't actually go further back, as if nothing else happened before, right? And as Michael Friendly puts it, there certainly have been many new things in the world of visualization. But unless you know its history, everything might seem novel. And I personally became absolutely in love for some of the things that I was discovering in these old medieval manuscripts. One of these discoveries was what's called the Volval. I don't know if you've seen that. It's also called the wheel chart or paper machine. It goes back hundreds and hundreds of years. It emerged in the High Middle Ages and was popular throughout the Renaissance. These were paper mechanisms, normally in a manuscript or lived on their own. It was either a single revolving paper wheel or a stack of paper rings that could be independently rotated, thereby permitting a large number of combinations at the intersection of all these moving disks, right? And a great example of how complex this could actually be was the example here on the left side. And they were actually very similar to early analog computers. On the left side, you have an example, a beautiful example of a Volval. This is actually a database of German language based on 5 predicate variables and letters inscribed in the edge of its 5 disks. Such a simple mechanism allowed the generation of up to 97 million words, right? 97 million words. I think especially at a time where big data is such a new, apparently or seemingly new phenomenon, looking at how such a simple mechanism made out of paper could actually generate a large number of outputs. Again, 97 million words. Another way of being in appreciation of history is by understanding that many of the visual metaphors and the diagrams that we keep creating today have actually been in use for a much longer period of time, right? This is actually the example of one called radial convergence. I labeled this method back in 2007, mostly because there was a lot of new cases popping up all the time. And I think going back to 2005, there were maybe 3 or 4 in the whole website that I was able to sort of see. But since then, since 2005, the model has really exploded, right? The trend is actually still very strong nowadays in what many people think is a completely new visualization metaphor altogether, right? But you have to, of course, to ask yourselves, is this actually really new? Is this the first time that humans have actually visualized information in such a way? And of course it's not, right? There's multiple examples that I've, of course, uncovered during my research that proves that we have been doing this type of model, and I could talk about many other models in the same vein during centuries, right? Here you have an example that goes back to 1275 by Spanish scholar Ramon Llull on the left side, who was actually trying to create this new combinatorial language, who actually, in the end, affected and influenced Leibniz, who actually was the father of binary code, zeros and ones that all of us use today. So fascinating stories underlying many of these charts, or even the example on the right side, which is those of you that have studied music might have seen diagrams like this. This is mapping a 12-tone scale showing the harmonies of a given musical composition. And this was massively popular during European Renaissance. And this is actually a juxtaposition in my book of circles. What's interesting about these two images is that they're actually separated by roughly 500 years. On the left side, this is an illustration, a chart created in 1549. And then on the right side, you have a much more recent one created in 2012. And I do think that history is quite often the target of bad reputation. In all honesty, I think all of us are present-oriented, right? And we tend to think of this moment in time as the pinnacle of humankind, the pinnacle of our civilization, and everything in the past should stay in the past somehow, right? That's definitely something that you hear very often in the circles that I go as part of Google. And a lot of my friends are actually very intrigued, like, wait, you work at Google? You work in one of the biggest tech companies in the world? Why are you looking at old medieval dusty manuscripts? And every time I'm posed with this question, I look back at this specific quote by James Baldwin, which I love, that says that history is not the past, history is the present. We carry our history with us. We are our history. And I think this specific quote really portrays the importance of looking back with a really keen eye for detail. Something else that I've uncovered or learned to appreciate is really how every single subject or domain can be depicted in endless ways. And of course, the famous quote by Alfred Korzybski always comes to mind that the map is actually not a territory. Then this should not be confused ever. The best analogy that I've uncovered to actually represent this is the following one. This is, I'm sure, a painting that everyone recognizes. It's arguably the most famous Japanese painting of all time, the Great Wave of Kanagawa, right? But what's interesting is that even though almost every single human recognizes maybe this, it's been such a popular sort of depiction. What many of you don't know is what's the main subject depicted in this painting. Many think it's the tsunami because of the presence, this like the wave that seems to be crushing the viewer. Others actually think that this is the fisherman's struggle with the sea. That's the main topic represented here. But the main subject, right in the backdrop of this painting, is actually Mount Fuji, right? The highest mountain in Japan. And in fact, this painting is part of what it's called the 36 views of Mount Fuji. It's basically 36 paintings depicting Mount Fuji from every single angle that you can think of, right? Mount Fuji is seen from the plains, from the city, from the ocean, right? And the famous one does that. From the farm, from, again, like every single viewpoint you can think of. And I think that's, where the metaphor comes at. It's like, think of your data set as your Mount Fuji, right? You can view it from endless angles, from endless viewpoints. And there's another example when it comes to this, which is every so often I open a website or I see it in the media, publishing an image like this one and saying, this is how the internet looks like. This is the ultimate map of the internet. And every time I see this like very clickbaity type of article, I always cringe a little bit. And then I go back to my sort of Mount Fuji analogy. And of course, this is not how the internet looks like. Again, this is one of many possible angles you can take to understand this really complex structure, which we call the internet, right? You can map it in endless ways. And this is actually just a collection of many maps of the internet. You can look at IP addresses, you can look at the backbone of the internet, online chats, the blogosphere, I mean, you name it. You could write endless books about all the possible ways of visualizing and depicting such a complex subject. So another thing I also learned in this like 15 years of research is it seems to be there's an increasing cross-pollination between science and art, right? And that's something that I especially discovered in my first book, Visual Complexity. And as it seems like as many of us, designers and scientists and researchers, map these really complex systems, these really complex networks, we are in the process influencing many artists, many of them from traditional fields like painting and sculpture. And in fact, this again is more pertaining to networks. Networks themselves are really becoming a cultural meme. They're driving the birth of a new movement that I called networkism, right? So here are just a few examples of this interesting cross-pollination between science and art. On the left side, you have an hand-drawn sketch of an insulin molecule by the Nobel Prize-winning British chemist Dorothy Hodgkin. And on the right side, you have a generative sculpture created using Vector 3 and Java that explores notions of affinity and difference. This is generative art. It actually doesn't exist, but it's still an art piece nonetheless. And again, this is the pinnacle of human science, that actually led to a Nobel Prize. And then here are another few examples. On the left side, you have IP mapping created in 2001. This is a computer-generated map of IP addresses, so computers, machines, servers. And then on the right side, you have transient structures and unstable networks created by Sharon Malloy using OL and NML on Canvas. And here are a few other pieces by the same artists called Transient Structures and Unstable Networks. Another example, on the left side, you have a computer-generated map of a social network called Operation Smile. And then on the right side, you have Field 4 by Emma McNally using graphite on paper. And Emma McNally's work, if you don't know it, is really fascinating. She uses this really dense maps that maybe only yourself kind of understands, but using, again, a really close resemblance to many of the computer-generated network charts that you see throughout visual complexity. And she uses graphite on paper. Sometimes they become really dark, filled with nodes and links throughout some of her work. But of course, networkism, if there is a movement, doesn't happen only in 2 dimensions. This is arguably one of my favorite pieces belonging to this movement. It's called galaxies forming along filaments, like droplets along the strands of a spider's web. It's created by Thomas Saraceno. Many of you probably know him. He's a famous artist. I've never been to one of these installations, but I've heard and I read that as you go through, these are actually elastic ropes. So as you bounce in one of these ropes, the whole network kind of shifts and reverberates a little bit, almost like a real network would, which I find quite poetic in different ways. And then, of course, this is almost networkism taking to an extreme, right? This is a piece called In Silence by Japanese artist Shiharu Shiota, where she uses elastic ropes and black woolen thread to fill this really large spaces, sometimes with objects only, sometimes with people as part of these installations as well. So apart from this cross-pollination between science and art, this is probably the last thing that I learned along the way is that UX and data visualization, going back to this split career, are actually siblings in this effort to make the invisible visible, right? So this is actually one of the most cited definitions of information visualization in this seminal work by Ben Schneiderman and others, where they say that they define information visualization as the use of computer-supported interactive visual representations of abstract data to amplify cognition, right? And in the same page further down, they say the following: a picture is often said to be worth 1,000 words. We can now argue that an interface is worth 1,000 pictures. And this is important specifically to understand some of the bad examples we have when it comes to network visualization, right? Sometimes we see things like this. They actually call these air balls, which is extremely hard to actually make any sense of, to be honest. They might be beautiful to look at. You could actually print it and have it hanged on the wall at your place. But can we actually use them? Is it actually usable, right, to begin with? And of course, I mean, surely, as many graphic designers in the audience will probably say, you can always improve the visual language of some of these projects, right? Using color, using line thickness, or richer notes to convey and express better the information that's underlying to them. But if you really want to have a proper understanding of a given information system from the inside out, you have to resort to interaction, specifically when it comes to mapping complex systems and complex networks. Seeing the overview, seeing the macro analysis, the pattern of a network, going deep into the linkage, the relationship analysis, and all the way to the micro analysis, the entities, the nodes themselves, and what they actually represent. And every time I think about this, I think about this specific quote by Ben Schneiderman that's also called the information visualization mantra. Overview first, zoom in filter, then details on demand. Those who are familiar with UX, this is also very similar to a principle called progressive disclosure, a very famous principle for interaction design. And in fact, I look at this, even though this is called the information visualization mantra, I think this can easily be also a UX principle or a UX mantra, right? And in fact, these are my favorite 20+ design principles that I've taught and spoke about over the years. And I look at this, and all of these principles are both UX principles, UX best practices or things to consider, and data visualization principles, right? I don't see any sort of divide here. So maybe not surprising that these seemingly separated paths, right, in my life, apparently like completely split, were actually, again, at least in my head, much closer than they would be in real life, with a lot of intersections and cross-pollination between them. And now at Google, I have to say, I think I was finally able to actually close that circle, taking another metaphor for circular diagrams, closing that circle and completely unify these two paths, right? And now I'm managing a large UX team of designers, researchers, engineers, very talented people working on many different cloud products, right? Google Cloud products, and also doing a lot of really interesting, really important data visualization work. We are actually building a whole component library to be used by the entire company to do things like the ones that you are actually seeing on screen. And we also recently launched a comprehensive data visualization spec, or set of guidelines for all Googlers across the company, right? So my last slide of this presentation and my final message to you is, please have a passion project. You never know the journeys you might undertake through this passion project. And if you're lucky to work in a place like Google, you can actually bring your passion project to work. Thank you so much.
Thanks so much, Manuel. We have time for a few questions. If you have a question, put your arm straight in the air and someone will run a mic over to you. No, there's Drew's going to be running that mic right over here. Anyone have a question for Manuel? Have you said it all? There's one right here. Here, Nigel.
Hi, Manuel. Thank you very much for a very entertaining presentation. What I was curious to learn about is, across your path and the intersect at the top right now at Google, when we see as consumers the output that Google does, and when it goes through a transformation and changes an interface, can we sense that degree of history that you're bringing to the table?
I don't know. I would say that's pretty hard. I don't think so. I mean, to be honest, I think my path has been a fairly unique one. Not that, I don't think everyone's path is unique, but in the sense that I'm in a tech company, again, like looking at medieval manuscripts. I don't think we have a lot of Googlers who do that, unless they are like, actually going through them and digitizing them. So I think my path is very unique in that sense, at least just talking to fellow Googlers at work. Yeah.
Anyone else in the audience have a question? Right at the back, Sarah.
Hi, Manuel, Sarah Diamond. That was a really inspirational talk. I wondered if you could talk a little bit about visualization in sort of 3D spaces, because part of what you, and you showed us this rich array of visualization examples and strategies, but we have these sort of parallel technologies emerging in the world, particularly VR and AR, and visualization hasn't worked well in 3D space. So I'm wondering how you're thinking about how we explore data in multiple dimensions.
Yes, and even going back in time, some of the first visualizations that I was tracking on visual complexity were actually attempting to be 3D visualizations. And this has been it actually goes back centuries, goes back to some of the early medieval examples of people thinking, and rightly so to a certain degree, that we inhabit a 3D space, a 3D environment. So instead of just coming up with new abstract metaphors, maybe using the space to memorize certain things, right? And it's very famous. They use like Rome stadiums, for example, and they have associated certain concepts with spaces in that stadium. So you could close your eyes and actually memorize where it was. So this goes back to that moment in time, goes way back in time. And then of course in the 90s, there was an effort of using the same sort of thinking, right? Like replicating, using sort of 3D environments to depict and convey information. It didn't prove to be very successful in the 90s, I think mostly because of technical constraints, right? I think they were maybe ahead of their time in that sense. We're still using very outdated machines back then, like really limitations in terms of like screen output and so on. Now, I do see there's a huge potential with things like VR and AI right now, which can really push the limits of what that could actually mean, right? There's also areas exploring multisensorial depiction of information. There's this beautiful, like large sphere in the University of California, Santa Barbara. I think it's a 3-story high, probably like the size of this structure. I've never visited, but I've heard of it. And they actually use not just images, but also sound. And they might be thinking about using smell. So it's a truly multisensorial experience. I think that's a huge sort of path forward for us to explore. But the only caveat I would put, and this is coming from someone who has a friend at Google doing very exploratory work on AR, augmented reality and VR as well. And they do this like 2-week sprints every so often where they try out a few different ideas. And one of these sprints was all about data visualization. And he called me up and said, hey, come and see what we are doing. Come and see what we are up to. And then I go there, I put these things, which is also, as you know, very intimidating. You never know what you're going to hit around you. And I just see a bunch of like bar charts and a bunch of pie charts, like static on this wall. And I'm thinking to myself, and of course I told him straight after that, it's like, why are you limiting your creativity in such a way, right? And I think that's really the challenge. Again, we try to sort of regurgitate old metaphors because we think either because we are going to understand them better or we don't really are very sort of courageous in pushing the limits of creativity. But I think there's something to say about really embracing a new technology and really exploring truly new visual metaphors. I think that's going to be the challenge for this century, really, is like, I think some of the visual metaphors we have, the visual models we have from the past are not enough to understand many of the complex systems that we're trying to map. You know, think about ecosystems or things of that scale and magnitude. You know, a bar chart alone will never be sufficient, right? So especially things with VR and AR, like let's really try to be really exploring that technology instead of just relying on old pre-existing models.
Thank you so much for that question. And thank you so much, Manuel Lima. That's all the time we have. Round of applause, everyone.
Thank you. Thanks, everyone.